In 2023, the James Webb Space Telescope pointed its mirrors at a patch of sky that astronomers assumed was completely empty. What it found broke three fundamental rules of physics. An object so massive, so ancient, and so impossibly bright that the senior research team initially assumed their own instruments were malfunctioning. So they recalibrated, they checked every sensor, they ran the numbers again. The object was still there. And according to everything we know about how the universe works, it shouldn't be. The team went quiet for 4 months before publishing their findings. And when they did, the paper contained a single word that sent the astrophysics community into chaos. That word was impossible. This is what they found. Each one of those points of light you're looking at, that's not a star, that's an entire galaxy. Hundreds of billions of stars, some of them so far away that the light reaching your eyes right now left before our planet even existed. And somewhere in that image, hiding in plain sight, is the object that may have just rewritten the history of the cosmos. Stay with me because this one changes everything. Before we get to what they found, I want to make sure you actually feel how significant this is. Because on the surface this sounds like another space headline, it isn't. The James Webb Space Telescope isn't just a bigger, shinier version of Hubble. It's something fundamentally different. It sees the universe in infrared wavelengths of light invisible to the human eye. That means it can peer through clouds of gas and dust that used to block our view entirely. It's like going from looking at the ocean from shore to suddenly having a submarine. And here's the rule that makes this discovery so earth-shaking. Nothing in the observable universe can be older than 13.8 billion years. That's not a guess, that's not an estimate. It's derived from one of the most precisely tested equations in all of science, the Lambda-CDM model, our standard model of cosmology. It tells us the universe began with the Big Bang 13.8 billion years ago, and everything we've ever observed fits neatly within that timeline. Or it did, until James Webb started looking. Now here's the other thing you need to understand, and this is the part most science videos skip over. How do we even know how old something in space is? The answer is something called redshift. Imagine you're standing on a street corner and a car drives past blaring music. As it approaches, the sound waves compress, the music sounds higher pitched. As it drives away, the waves stretch, the music sounds lower. That's the Doppler effect. Light works the same way. As the universe expands, the space between us and distant galaxies is literally stretching. That stretches the light traveling toward us, shifting it toward the red end of the spectrum. The more redshifted a galaxy's light is, the farther away it is, and the further back in time we're looking. It's a time machine, and James Webb is the most powerful one ever built. So here's where things start to get uncomfortable for the people who write cosmology textbooks. In the first year alone after JWST became operational, astronomers discovered not one, not five, but dozens of galaxies that appear to be far too massive, far too bright, and far too structured for how early in the universe they exist. According to our best models, a fully formed galaxy with stars, structure, chemical complexity should take billions of years to build up. It's not a fast process. Dark matter halos need to form. Gas clouds need to collapse. Generation after generation of stars need to live and die, forging the heavier elements that future stars and planets need. It's cosmic construction, and it takes time. But James Webb is finding finished skyscrapers in what should be an empty field. One paper after another started arriving with the same quietly panicked subtext: "This shouldn't be here." Researchers began using phrases like tension with lambda-CDM and challenges current models, which, in the language of science, is roughly equivalent to screaming. And then they found one that didn't just challenge the models. It seemed to shatter them. The object in question, based on findings associated with galaxies like JADES GS-Z14-0, is among the most distant and therefore most ancient objects ever confirmed. Its redshift measurement puts it at over 14, meaning we're seeing it as it existed just 290 million years after the Big Bang. That's 290 million years, out of 13.8 billion. To give you a sense of scale, if the entire history of the universe were compressed into a single calendar year, this galaxy existed on January 3rd. And it shouldn't be there, not like this. It has a mass equivalent to hundreds of millions of suns. It's producing new stars at a remarkable rate. It's luminous, far brighter than models predict anything could be at that stage of cosmic history. Our current models say the universe at that point was essentially a fog, a warm, dense soup of hydrogen and helium slowly clumping under gravity. There wasn't enough time, not nearly enough time, for the universe to have built something this complex. Astronomers use a simple analogy. Imagine finding a fully functioning city, skyscrapers, highways, power grid, on a plot of land that was a forest 6 months ago, and you have no explanation for how it got there. That's what James Webb is showing us, repeatedly. So either our timeline is wrong, or our physics is wrong, or something else entirely is going on. Here's where the scientific community is right now, and I want to be clear. This isn't fringe conspiracy territory. These are peer-reviewed papers from institutions like MIT, Cambridge, and the European Space Agency. This is the mainstream frontier of cosmology. There are several leading theories on the table. Theory 1: dark matter behaves differently than we assumed. Current models treat dark matter as cold and slow-moving cold dark matter, but some physicists are now suggesting it could be warm or interact in ways we haven't accounted for. That would mean structures could form faster in the early universe. It's not a wild idea, it's actually testable, and James Webb may already be giving us the data to test it. Theory 2: the first generation of stars, what we call population III stars, were far more massive and energetic than our models predicted. These were the universe's first suns, born from pure hydrogen and helium, and we've never directly observed one. If they were extraordinarily large and burned extraordinarily hot, they could have seeded structure at a pace our models never accounted for. Theory 3, and this is the one that keeps cosmologists awake at night. What if the universe isn't 13.8 billion years old? A small but growing number of physicists are revisiting the foundations of how we calculate cosmic age. Some are taking a second look at an old, largely dismissed idea called the tired light hypothesis, the suggestion that light loses energy as it travels through space rather than the universe actually expanding. If true, our entire distance scale and therefore our age estimates could be off. I want to be careful here because this is not the scientific consensus. Most cosmologists still firmly believe in the standard model, but the fact that any credible researchers are revisiting these foundations tells you something important. The cracks are real. And here's the thing about cracks. They're how light gets in. What James Webb may be telling us gently, persistently, through image after image, is that the universe has a chapter we didn't know existed. An era before our era, a cosmos before our cosmos. The light from these early galaxies has been traveling for over 13 billion years to reach us. It left before our solar system existed, before Earth existed, before life existed. And here it is, landing on a mirror we built and being decoded by minds we grew. That's not just science, that's something almost beyond words. We may be living in the second act of a story whose first act we can never fully read. And the most honest thing science can say right now, the most human thing, is, we don't know, and that's extraordinary. Because every time humanity has hit the wall of we don't know, we've eventually broken through it. And James Webb is handing us the sledgehammer. If this made you see the sky a little differently tonight, I'd love for you to stick around. Next week we're going even deeper. The Hubble tension, a crisis so significant that physicists on opposite sides of it can't even agree on how fast the universe is expanding. Two methods, two answers, both correct, and they can't both be right. It gets stranger, I promise. Hit subscribe so you don't miss it, and if you want to keep the conversation going, drop your biggest question about this video in the comments. I read every single one. See you next week.